Hello class. Today we're going to be looking at lesson number 7 in our note package. So we can flip to that now. If you want to pause, I'll give you guys a bit of time to get to that. But what we're going to be doing today is we're going to be looking at how we can solve exponential equations while using our logs. The first little bit here is a review. So this is what we've done before. We did this back in our exponential part of this unit, where we're able to solve out for x, where we create the base the same for both ways. So for example here, we have 2 to the power of x is equal to 32. Well, I want to make sure that we have our base here of 2x, and that over here with my 32, I want to have that as a base of 2, 2. So we need to find that 2 to the power of something is going to equal to 32. So if we look at our different options, we have 2 to the power of 2 is 4. 2 to the power of 3 is going to be 8. 2 to the power of 4 will be 16. And then 2 to the power of 5 will be 32. So that is the one that we're looking at for here. So we can rewrite that by saying 2 to the power of x is equal to 2 to the power of 5. Well, once I have the same base here, what I can do is I can get rid of that base. We're going to cross it out, and we're just left with x is equal to the power of 5. And this is one way we're able to solve it out when we have the bases the same on either side of the equation. Looking at b here, we have 4x to the power of, to the power of x is equal to 2 to the power of x plus 3. Well, we have two variables on either side of the equation here. We have one on the left side, one on the right side. So if we want to be able to solve this out, same way that we did in example A, I want to have that base the same. So in this case here, well, we looked up here, 2 to the power of 2 is going to be 4. So for this case here, what we're going to do then is we're going to go 2 to the power of 2 times x is equal to 2 to the power of x plus 3. Well, what's 2 times x? 2 times x is just going to give us 2x, right? So 2 to the power of 2x is equal to 2 to the power of x plus 3. Once again, we have the same base. We can get rid of that base, cross it out. We are now left with 2x is equal to x plus 3. What we want to do here is we want to isolate the x, get x by itself. Well, if I have x on two sides of the equation, left and right, what I'm going to do is I'm going to move the x to the side with the bigger one. So I have 2x on the left-hand side and an x on the right-hand side. I want to get rid of this x and move it to this side. So to do that, I'm going to do whatever the opposite is. This is a positive x, so to get rid of it, I'm going to subtract x from this side. And I'll do that to the other side too. Whatever I do to one side of the equation, I always have to do to the other side of the equation. So over here, we're going to end up with 2x minus x, which will give me just x. Remember, we have like an invisible 1 in front of that x. We don't always put that in, but we do have the invisible 1. Well, x minus x is going to cross themselves out, and we're left with x is equal to 3. So our final answer in this case here would be x is equal to 3. So that is one way we're able to solve out our exponential equations. Another way is we can be able to use logs. So the way that we do that is, first step is we're going to change our exponential equation into a log. So we want to change this into a log. We want to then isolate the power and then solve for x. So in this case here, we're looking at 5 to the power of x is equal to 200. Well, remember our log bx is equal to y is the same thing as saying b to the power of y is equal to x. So all I'm doing is taking my exponent and I'm turning it into a log. So this case here, for my 5, I'm going to change it into log. My base stays the same, so we're going to have log of 5. And then I'm looking over here, y is going to be to the power, which is going to be equal sign here, And whatever my x is, that's going to be my argument, right? So we're going to have log 5, 200 is equal to x. Well, to solve that out, what we're going to do then is we're going to remember when we have our base, an argument, and some of your guys' calculators, you can put this straight into your calculator if you have a TI-84, but anybody else using different calculators, what we need to do then is go log 200, so our log of our argument, divided by our log base. And we're going to use our calculator, so on log 200, bracket divided by log 5. And we'll end up with x is equal to 3.29. So that's one way we're able to do it, by converting to logs. Another way we can do it is our method 2, is what we use the equation rules. So what we're doing in this case here is we're going to go log 5 to the power of x is equal to log 200. So what I did here is I'm taking the log of both sides. So what I do to one side, I'm going to do to the other side of the equation too. So I'm just putting a log beside each one. Well, if you think back to our powers rule, from our logs, whenever we have a number to the power of something, well, I can take this and put it to the outside. So we end up having x log 5 is equal to log 200. Well, this means x times log 5. So how would I get rid of this log 5 here to isolate the x out? We're going to do the opposite of timesing. Timesing is going to be dividing. So if I divide both sides by log 5, what happens here is I'm going to isolate the x by itself. And we're going to go log 200 divided by log 5, which is what we did for the other one. We're just doing it in a different way now, right? 3.29 will be our answer. Well, our third way of doing it, our third method is we can do this through our calculator. So remember when we have our 5 to the power of x is equal to 200, what I can do is we can go y1, y2, and then we're going to find the intercept. Find where those two lines will intercept with each other. So on my calculator, what I'm going to do is go y equals 5 to the power of x. So power to the power is going to be that half x. And then below here, I'm going to enter in 200. I'm going to go to my window. I'm going to change my x maximum to 10. I like to have it 10, negative 10. On my y maximum, I know I'm going to have to be above this 200. So I'm going to change my y maximum to about 250. And then hit graph. Well, that's our exponential function, and then we have our line come across. So my next step is going to go second calc, or second trace, number 5, intersect. First curve, I'm on the first curve, I can hit enter. Brings me up to the straight line, which is my second curve, hit enter, and then I want to guess, and then we'll care where it is, so I hit enter, and we get the same answer there. X is equal to 3.29. Why we want to be able to do these ones, this method, is if you're ever asked to algebraically solve out some of these equations, especially exponential equations, and we're not able to do come up with the same base, so sometimes that is impossible, what we can do then is we can use the log method to be able to solve those exponential equations. So let's look at how we do 3x is equal to 54. So the first method I want you guys to look at is we're going to change it to logs first. So just remember, this is on your guys' formula sheet too. We have our log of our base, x is equal to y. B to the power of y is equal to x. So first way is I'm going to change it to a log. Well, that's going to be, okay, my 3 is going to be my base, so log 3. My equal sign here is going to be my x value, so 54 is equal to x. Once again, what we're going to do is we're just going to be able to solve that out now. We're going to go our argument, log of 54, divided by our base, log of 3. And we can do that on our calculator. Log 54 divided by log 3. And we end up with, well, one thing I might have done wrong here. If you look up there, I didn't put my 54 in brackets. So that is a mistake. I should always make sure we close our brackets off here. So log 54 bracket divided by log 3. And that will give us our correct answer there. So 3.63. So just be careful when you always put in that in your calculator. So the first one, we have two different answers here. So what it did here is it took the log of 54 divided by log of 3. What we're going to do is log 54 divided by log 3. And that's why we got it wrong. Our equation rules now is what we're going to do is we're going to give the log of 3x is equal to the log of 54. We're just going to take both of our numbers and put a log in front of it. Well, my law of power says that I can move that x over here. So we're going to have x of log of 3 is equal to log 54. Well, I want to isolate this x out by itself. So I'm going to divide both sides by log of 3 to get rid of this. And we have x is equal to 3.63. So that's how we would do those ones. So what happens now if we have an equation here? We have x to the power, 8 to the power of x plus 4 is equal to 40. Well, my first step is I want to isolate the power. I want to get this x, 8 to the power of x, by itself completely. So I'm going to do the opposite here of our plus 4. So to get rid of my plus 4, I'm going to minus 4 from this side and minus 4 from my other side of my equation too, right? So these are going to get crossed out. We have 8 to the power of x is equal to, well, 40 minus 4 is going to be 36. So my first method, if I want to change it to logs, well, we're going to have log of 8 as my base. My argument is going to be 36 is equal to x. So we're looking at this one here. So we're going to get log of 36 divided by log 8, where our x is going to equal log 36 divided by log 8. We're going to get 1.72. Let's go to the nearest hundredth. We can use the equation rule to be able to solve it out too, or we're going to have similar. We're going to go log of 8 to the power of x. I'm just going to take the log of both sides of these equations, right? So log of 8 to the power of x is equal to the log of 36. What I do to one side of the equation, I do to the other side. So they are equal. Well, my power law tells me that I can move my x over here. So if x log 8 is equal to log 36, x is equal to, well, we want to get rid of this log 8, sorry, jumping ahead. We're able to cross out those log 8s now by dividing both sides by it. We're going to have, move this down, x is equal to log 36 divided by log 8, where our x is going to be equal to 1.72. And that's how we were able to do that. Well, let's look at the next one here. We have 100 is equal to 3 times 2 to the power of x. How the same thing that we did before, we want to isolate this 2 to the power of x by itself. We want to isolate the power. So to be able to do that, what I need to do is get rid of this 3. Well, how would I get rid of this 3? Well, this is 3 times 2 to the power of x. To get rid of this 3, what I need to do is divide both sides by 3. Those 3's are going to cancel out, and I'm going to be left with 2x is equal to 100 over 3. Well, I left it as 100 over 3 because if we put 100 over 3, 100 divided by 3, we end up with 33.3333 repeating. So I'm just going to leave it as a fraction for now. And we'll be able to put it in our log as a fraction. So we have it now as a singular exponential equation. So we're able to solve it now using logs. My first bit here is I want to change it to logs. Well, our base stays the same, right? So log of 2. And our argument then is going to be what it's equal to. So 100 divided by 3 is equal to x. So when I put that in my calculator, I'm going to go log 100 divided by 3. I've been saying 103 maybe. Divided by log 2. So if I want to put that in my calculator, I'm going to go log 100 divided by 3 divided by log 2. And then here I'm going to get 5.06. We'll round up to the nearest 100. Well, similarly, our equation rules allow us to set up where we do a log of both sides, right? So we can do log 2x, 2 to the power of x, is equal to log 100 divided by 3. I can move my x's in front. So I have x times log 2 is equal to log 100 over 3. And to get rid of this log 2, I'm going to divide both sides by that log 2. Those will get crossed out. I'm left with x is equal to 5.06. So the most important part is when we're going through these is if we have an exponential equation where we have the power by itself, we can convert straight into logs or use equation rules. If we have the power, so 8 to the power of x, is not by itself, we need to isolate it first. So we need to get rid of anything around it first, bring it to the other side, and then solve it out. So then we can put it into this form again, and then we can change it to logs or use equation rules. Our last two examples here. Now what happens if we have, bring that down a little bit. What happens when we have like 3 to the power of x minus 1, when x isn't by itself? How do we solve that out? X plus 1. I think it's is it x plus 1 or x minus 1? It's hard to read. X minus 1. So for us to be able to solve this out, what we're going to do is we're going to be able to still change this into log form here. So then we're going to have log of 3 with an argument of 20 is equal to x minus 1. Well, my next step here is I can do my log of 20 over 3, right? So we're going to go log 20 divided by log 3. And we're going to get 2.73. We'll round up to the nearest tenth here. 2.73 is equal to x minus 1. Well, I can't leave that as an answer, right? So what do I need to do here? Well, I need to get rid of this minus 1 here. To do that, all I need to do is go plus 1, plus 1. The negative 1 and the plus 1 are going to cancel itself, so we have isolated our x. So in the end here, we're going to have 3.73 is equal to x. So at the end there, what we're going to do first off here, we're still going to do our log 3, 20, and then at the end here, we're going to isolate that x out. So the last step is going to be isolating the x out when we have it to the power of an x minus, plus, minus something, right? So similarly for b, we're going to do something similar too, right? So I want to convert this into my log. So log of 5, argument of 104, is equal to x plus 2. So we can do that on our calculator, where we do log of 104, our argument, divided by log of our base, which is 5. And then we end up with 2.89 is equal to x plus 2. Oh, still got to isolate out that x, right? So to do that, what I'm going to do is subtract 2 from both sides. So my plus 2 minus 2, those get canceled out. And then 2.89 minus 2 is going to be just 0.89. So x in this case is going to be equal to 0.89. If we ever want to double check this is something that we should have tried before, I can just replace in the equation there my x with my value that I've calculated out, right? I'm probably not going to get the exact same number because I'm rounding, but I should get very close to 104 when I go 5 to the power of 0.89 plus 2. And I get 104.7. So it's not quite as, it's very close. We're still getting within 1. And we're losing that because we are rounding a bit. If I put in the exact answer from log 104 divided by log 5 minus 2, and then I go 5 to the power of bracket. Always, if you have equation in your exponent, always put it in brackets, of second answer, this is going to pull the answer from there, plus 2. I guess I didn't need to subtract 2 because it's taking our full answer from here. We're going to hit enter, and I get 104. The only reason why we get 104 exactly in the last one is because of our rounding. And we usually expect you to round your answer too. The last one, this one is a lot more, this is our most complex one that we're going to do today. So example 3 is we have a power to the power of x on both sides of our equation. So we have 5 to the power of x is equal to 3 to the power of x plus 2. Well, what happens now if we have to the power of x on both sides? We're going to be using, the first one here, we use our change to logs method. We're going to be using our equation method. Oh, it's really badly written. Here what we did was we did our change to log method. My nice writing there. This next one here, if we have x on both sides, we can't do the change to log one. What we're going to do is we're going to do our equation method. I want to show you why. So first what we're going to do is we're going to do log of 5 to the power of x is equal to log of 3 to the power of x plus 2. So all we're doing here is we're just doing a log to both sides of the equation, right? So I've logged both sides of the equation. Well, remember what do we do with this to the power? I can take this and bring it over here for both of these. So over here now I'm going to have x times log 5 is equal to bracket x plus 2 times log 3. And this is where it's going to get more complex right in here. Where we have a binomial, we're multiplying it to a log of 3. We're going to have to end up distributing that log of 3 into it. When I talk about distributing, remember all we need to do is this log of 3 is going to get multiplied into both of those terms. So we're now going to have x of log of 5 log 3 plus, well, 2 times log of 3. Think of it, there's like a 1 in front of this log. And what I'm going to do is multiply that 2 3. So what we've done is we've distributed that log 3 into both of those terms there. Well, this doesn't look like where you've gone too far, right? Well, you remember how before when we had an x on both sides over, oh sorry, yeah, no, over the first one? Oh, way back at the very beginning. Sorry, my bad. When we had an x on both sides for our equation here, well, what did I end up doing? I brought my x over to one side. We brought all the variables to the same side, right? So we have to so we have x log 3 plus 2 log 3. Well, to get rid of this one, I'm going to subtract x log 3 from this side, and which means I have to do it to the other side, minus x log 3. Those will get crossed out, and on this side here I'm going to have x log of 5 minus x log of 3 is equal to 2 log 3. So we're able to cancel those out, right? Well, looking at this here, we have an x on both of these. I can pull that x out of it, right? So think of this as like a binomial. Think of this as like if we had x we could go x times x plus 1. That's what we would be able to do. I can pull that x out of it. Think of this similarly as a binomial where I'm looking at this number here. I can get rid of an x, right? I can pull that x out. So I can go x, because we have an x in both of these, bracket is equal to 2 log 3. Now, we have x times our log 5 minus the log 3. Well, remember when we talked about before is what we want to do is we want to isolate that x out. So if I want to isolate the x out, what I'm going to do is because we're saying this whole x is multiplied by that. What I do to one side, I have to do to the other side. Log 5 minus log 3. Well, this whole thing gets crossed out, right? We're just left now with x is equal to 2 log 3 divided by well, do you guys remember our log laws that tell us what happens when we have the same base and we subtract two things? We're going to end up dividing it, right? So we could rewrite this out again, which makes it easier to put in a calculator. 2 log 3 divided by log of 5 divided by 3 in brackets, where the 5 divided by 3 is going to be an argument there. Later. So I'm going to go 2 log 3 5 divided by 3. Enter. And I end up with 4.3. So after all that work, what we've discovered is x is equal to 4.30. Because we'll round up to the nearest hundredth in this case here. It is a longer process. We have to be careful here when we need to distribute that law into both of our and then it's just isolating x out by itself. When we have our two x's here, I can pull it out, right? So basically what I'm doing is I'm dividing this, taking the x out of this whole binomial. Think of it as it in brackets. And then I'm just pulling the x outside the brackets. That is our example of how we're able to use exponential equations and our logs to be able to solve those out. They can ask you guys on the diploma and on your unit exam, you will be asked to do something similar to this, where you have to be able to solve out a log or an exponential problem, an exponential equation, and put it into log form. Where we won't give you like an x is equal to something, we'll give you something like this in the end, where you have to get to that point. Alright, well, the rest of the day here you can work on your worksheet. If you finish your worksheet, make sure you're in your workbook, working your to 5 in your work booklet. If you haven't started working your way through, it's great extra practice. Next week on Thursday will be your guys' test. Monday into Richter scale. pH is very similar to Richter scale. You do it in the same way. Or look at decibels. And then finally, we're going to look at regressions involving our logarithmic functions. That's always a tongue twister for me. So after we're done all of that, you'll get some time to review, and then your test will be Thursday. All right, thank you for listening. I hope you guys have a great rest of the day and weekend.